This conference will now be recorded.
So today demo session, we will understand about practical understanding of data science. So let me start the session. So the topic is data science, and we are going to a little deep dive into how it is linked, what are the main components of data science, and different pieces which it connects and all that stuff. So before getting further into it, let me talk about myself. My name is Sitaram, and I have around 15 years of experience in IT, out of which around 8 years I have in the data area. I worked as a big data architect before, and currently working as a data scientist for one of the popular MNCs. And I also do trainings. In fact, teaching is my passion. I also do this as a part-time gig, and from an education perspective, I have MTech in BITS Pilani in data science, and I'm pursuing my PhD from IIIT Hyderabad, and that also in deep learning and computer vision. So these are the details about me, and definitely through the session you would understand my teaching style. So mostly we would use this kind of a blue board for drawing certain things and understanding few things during today's session. If you have any questions, I would recommend to use the chat window. There's a chat window available. Or if you think it is very important to ask the question, then take a time, see the right time, and then you can ask. I would also allocate few places where I'll ask for any feedbacks and questions. So if you have any questions, you can use the time and then ask. All right, so without any ado, let me start. So in the data science part, or primarily if I take the data analysis and all these things, it was not a new thing. It is happening for many, many years. For the past few years, it is happening. For many, many decades also, it is happening. So if you take the older way of how the data science used to work, companies used to send data, their primary businesses. For example, they are in the retail business or some other business. They used to send data to RDBMS databases. Now, RDBMS databases were the primary source in which they used to store the data. Now, RDBMSs, we can call them as ODS. ODS are operational data stores. They are used for storing your operational data. What is your operational data? Imagine you are a retail company. Your operational data will be what did you sell today, how many kgs of rice, how many liters of oil, how many packets of milk. So all these things will be your regular day-to-day transaction, and all the transactional data are being stored in ODSs. These are SQL databases, and you'll store these data in the SQL databases, and you would use for further storage. That is used for tracking purpose, that is uh, used for analysis purpose and other things where the data is being stored. Now, initial data science or data analysis used to happen on these Oracle databases or SQL databases, MySQL or SQL Server databases only, where people used to write SQL queries. So people used to write SQL queries on these databases to understand now how many kgs of rice sold, how many liters of oil sold, and how many packets of milk sold, and so on. So if you are or really wanted to do some data analysis to identify the demand and the supply, people used to run the SQL queries on these ODSs so that they used to get the results. And this used to be the regular norm in which the data analysis used to happen. Front-end businesses used to dump the data into ODSs, and then back-end people used to write queries to understand the demand and the supply of the data and so on. So this is good. People used to enjoy this, and there are a lot of work used to happen. But what sometimes what used to happen is the front-end transactions which are interacting with the databases, sometimes they get slow because there were some updates happening in the back end, and the SQL queries are also running. So sometimes if there are inserts happening here and then updates happening here, probably there is some kind of a lock situation happening, and the databases get slower. So initial years, people used to see this kind of some lags and delays, and because of which then people decided that let us not run the SQL queries when the business hours are happening. For example, 9 to 5 is a business hour. Then people decided that let us not run our SQL queries during this time. We will not run during the active business hours. We will run when there is off business hours. So that's when your nightly jobs came into picture. Nightly jobs are the jobs which are the same SQL queries, but these jobs are not running in the business hours, but they are running in the off business hours. So you might have heard that batch jobs, night jobs, and so on. So those are all kind of byproducts of these of what has happened. Okay, so people started running these nightly jobs, and things were working pretty well for many years again. um, these nightly jobs used to run during the off business hours, so no impact to the business and all, and things used to run quite well for many years. In 1970s or so, ODSs started, or SQL databases started, and these jobs were running for many decades. And in the earlier internet era, when there was an explosion of internet, and also the companies went geographical. They went to different geographical boundaries. They are not confined to US. Now they have expanded to, say, like Australia. They've expanded to Singapore, Dubai, India, and other places. Now what happened is, now there was no such lean time where the number of transactions were minimal, right? So the businesses grew. They have grown their offices at different parts of the world, and because of the advancements in the internet, they have created online presence, and these bookings were happening 24/7. And because of all these advancements, there were never a time which we can say that, okay, this is the lean period. When US was off, other parts of the world were on, maybe like Japan or Australia, Singapore, Dubai, UK. So different parts of the world were active at different times of the day, and because of that, what happened is these databases were never in a lean period. No, the nightly jobs cannot run, because when the nightly job run, one or the other country was active, and it was creating issues for the transactions which are running on that geography. Now, what people decided is, let us not touch these ODSs. Now we will find a small lean period where we can create a dump of this and not touch these ODSs, and we try to run our analysis somewhere else. So that's where this data warehousing thing came into picture. People created something called as data warehouses. Now data warehouses has great advantages. DWH, or data warehouses, is where it started creating, where the nightly jobs, instead of running on the primary primary SQL databases, they used to run on the data warehouses. Now, what are these data warehouses used for? Definitely, the first and prime purpose was to decouple the transactions from the real databases. So we can decouple, so the databases can be free from these nightly jobs, and these nightly jobs were run on the data warehouses, so that there is no impact to the actual transactions, whatever part of the day it is. Now, there used to be a small lean time where the dump used to happen. That is to call as ETL process. ETL process is like extract, transformation, and load. So you extract from the data, do some transformation, and then load them into the data warehousing solutions. Now this ETL process is become very famous because now you can do a lot of kind of transformations, a lot of key concepts can be involved here. You could do joins, merging, and other things. A lot of things can be done, and that has created a lot of flexibility. Another great advantages of data warehousing solutions is that now, while the operational data stores are capturing the data in a live situation, for example, as is today, whatever is happening, that will be available in the operational data stores, whereas the data warehouses are capable of storing huge volumes of data, huge volumes of historical data. Now I can store last week's information, 1 month back's information. I can store a 1 year back information, and so on. So whenever I want to do some historical analysis, then I could very easily choose data warehouses. I can clearly get a pattern. I can clearly get what has changed, what has updated, what has gone good, what has gone bad. So a lot of analysis can be done when you have historical data, and that is one of the greatest things which data warehouses also has provided. Now, using the data warehouses, people have created a lot of reporting systems. They will be used for reporting, monthly sales, weekly sales, change in the data, and different kinds of reports are being created. And definitely, there are a lot of applications over that. Now this is good. Things were going very fine. People were using data warehouses. It started 25 years back, and now still in many of the corporates, people are still using data warehouses because they're very powerful. They're very flexible. People have already experienced working with them, and there's very good. But what happened is the data warehouses were primarily a source of structured data. Structured data in sense they are in the structured format, like in a row column format. They 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 will be capturing like rows of information, columns of information. Like first column is a string, second column is a double, third column is an integer. Likewise, we have a proper row column data, and that data is being stored in data warehouses. Primary storages. Of course, there are people who are creating different patterns of data warehouses also, but primarily the data warehouses are focusing about storing structured information. That is good. But whenever there are unstructured data which is coming into picture now, because of the explosion of the data, there's a huge amount of data which is coming from different parts. Now there are videos coming up, there are text data, image data, sensor information. Likewise, we have huge volumes of different unstructured data coming into picture, which we are not able to store in the data warehousing solutions. And what people created is, instead of just the data warehouses, they created something called as data lakes. So they called them as data lakes. Now, what are these data lakes made of? They are made of some big data or cloud computing based services, which are now able to store huge volumes of data of unstructured nature. One of the very common one is Hadoop. People, you might have already heard about it. Hadoop was a primary data lake, and that is used for storing huge volumes of data. In the similar lines, nowadays people are venturing over cloud-based solutions like AWS cloud, or say like Azure cloud. So these are some of the common solutions which are used for data lakes. Data lakes is where you're storing that information. Now, what all information is coming into the data lakes? People are, putting videos. So videos can be part of the data lake. We can have images. Now image of a mountain and some lake. We can have some textual data. I could say maybe a log data. So log data can be part of it. You could have some sensor data. The sensors coming from say like IoT and other different manufacturing units. You can have some textual data, maybe like plain text or any other kind of text. So these are a few of them. Now there could be even more patterns of data. I'm just kind of creating some few patterns. So what has data lake created is it has created a um, storage solutions now which are capable of storing different types of different structures and different patterns of data. It could be videos, images, log data, sensor data, textual data, or the regular ODS pattern data. All the data can be captured at one single place. Now this creates a bigger opportunity, from a job perspective. Now this is a bigger area where people are already working on. Now this is called as data engineering. You might have heard about the word called as data engineering or data engineer. So data engineering is a place where we are kind of creating data storages, kind of running some queries, doing data ingestions. Now when these data has to come into the storages, now you have to use some ingestion services. That could be maybe like Kafka. You could use storage services which could be like Scoop. You could use some other storage services like Flume, some FTP services, Flume services. So likewise, so there are a lot of these ingestion services which are basically ingesting the data into the data lakes. And of course, we also need to maintain the data lakes. We have to maintain the Hadoop servers or the AWS servers for actually capturing the data. We need to plan for the expansion of the data. If the data is expanding at a particular pace, we need to ensure that the same amount of storage is available for to meet those expansions and all that stuff. So the work of a data engineer will kind of work on all these things. A data engineer will also do some kind of transformations, like changing some data, joining, removing some columns, adding some columns, doing some internal transformations. All those things will be done by a data engineer also. So the primary purpose is to clean the data and then keep it ready for the consumption. Now, once this part is done, the next important part is where it's called as exploratory data analysis. Exploratory data analysis. Now, this is a piece where there is a lot of exploration happening. Now, exploratory data analysis is kind of a pre-processing technique, which is done after the data is ready, so that we do the exploration of the data, identify different parts and pieces of the data, and then performing a lot of activities. Those are some pre-processing activities. So we could do pre-processing, we could do some transformation. So transformation, you can apply some techniques like encoding. You could do something like scaling techniques. You could do something like um, normalization. Right, so I'm just writing a few of them. You can do missing value imputation. Likewise, there are a lot of them. So what we do is we try to transform the data. We try to create different types of patterns of the data. We try to pre-process. We try to do something called as encoding, scaling. So whatever data is being sent, so this is in a raw format. Whatever the data is in the data lake is in a very raw format. The raw format data has to be transformed so that we can create it in a consumable way for my models to work. Now, models are the algorithmic processes which will try to look at the patterns of the data, and based on the patterns of the data, they will try to do some future predictions. But for my models to work very well, what we have to do is we have to clean the data, we have to explore the data, identify the right clues from the data, which can give better results. Now, when you feed garbage, now this particular raw data might have a lot of garbage. A huge amount of data will be there, and a lot of garbage will be there. So one piece is where you try to have a lot of garbage. When you have that garbage, basically have to do a lot of pre-processing and do a lot of cleaning techniques and so on. Now, once that cleaning technique is done, then you basically have to transform that data into multiple systems and do multiple um, uh, projects accordingly and so on. So once the garbage data is removed and you clean the data, you can feed the data to the modeling systems, and modeling systems will be using it for doing further predictions. So the next step is what we call as modeling. Now, modeling is where you apply a lot of algorithms. Now, this is where a lot of people will talk about AI, ML, and other things. I will give a general name called as modeling and algorithms. Right, so we'll not go deeper into it, but just understand that once the data is cleaned, we will try to apply these modeling techniques. There will be a lot of modeling techniques. You have supervised techniques, which again are divided into classification and regression. Again, here we will have further a lot of techniques. We have unsupervised, we have reinforcement learning techniques. Likewise, there are a lot of modeling techniques which will be applied. So if I go detail in classification techniques, there are plenty of classification techniques like a random forest, decision trees, k nearest neighbors, support vector machine, grid boosting. So likewise, there are huge different techniques which are involved, which will be used for doing classification itself. And in the similar lines, we have regression techniques, we have unsupervised techniques like clustering and other things. Similarly, we have reinforcement learning techniques, which will be advancements of supervised machine learning techniques. So all these techniques will help us to find the patterns of the data. Based on the patterns of the data, it will try to do some future predictions. Now, future predictions, we will use the future predictions for getting some output results. So let me take an example. If you want to, if there is a bank, some XYZ bank, and that bank is wanting to identify loan eligibilities of people. People are applying for the bank for applying for some loan, and the bank wants to know like what is the credit worthiness of the candidate, whether it is a good thing to provide loan to the person or not. Then based on that, bank has a lot of information in the past. They have a huge amount of information of the people, of the past loan history and other things they have already given to similar people. and based on that experience, the bank will decide that okay, we can give the loan for this person, and this much will be the loan amount. Now, if a bank wants to automate this process using machine learning, now what we can do is we can gather huge amounts of data of past loan data. Now, for the past 3 years, we can collect all the loan applications, their approval and rejection process. And if it is approved, we can also collect like how much amount was approved. Now, with that data, we can feed that to the machine learning modeling, and the machine learning model will identify all the patterns. What are the conditions in which it is giving loans? What are the conditions in which it is rejecting loans? All those things, it will create a extraction of that patterns, and it will call it as a model. The model is nothing but the extraction of all these rules based on which it can further do predictions. Now, today, imagine I got a new person who is wanting a loan. So he comes back. Then we can ask few questions. Now the model will expect some few questions. It will check like what is the age of the person, what is the bank balance, what is the salary of the person, are there any liabilities, are there any existing loans, is the person married, if he is married, does he have any kids. So likewise, there are a lot of these questions, and based on the questions, based on the answers of the questions, the model will predict whether to give a loan or not. If at all the model predicts that we can give a loan, it will also predict how much loan can be dispersed. So when we are predicting whether the person has to be given a loan or not, that falls under something called as a classification use case. We are classifying the candidate to whether he is eligible for loan or not. That is one case. Upon the classification of the candidate is worthy of a loan, then we can also determine how much loan to be dispersed. That will be into the regression case. Regression will tell that it will predict the number terms. It will predict what is the numerical values of the loan, like how much loan can be dispersed. It is like 10 lakhs, 15 lakhs, 22 lakhs, whatever that number is. So that is the regression value, whereas the classification determines whether the person is eligible for the loan or not. Yes or no, true or false, or maybe approved for the loan, rejected for the loan, pending with the pending with the main branch or something. There could be more than one class, right? So based on the output of the data, we will try to determine whether we will use a classification algorithm or we will use a regression algorithm, and so on and so forth. Now, this modeling, whatever is a process in which it takes the data, tries to apply the patterns of the data, come up with an executable model, that is an iterative process. Now, this is not a one-time process. It is basically runs in a loop, because the first time whenever it is doing, it might get some amount of accuracy, saying that okay, I have predicted and this is how much I am getting as an accuracy. But every time we would like to improve the accuracy of the model, so that the every time the more times you try to improvise, your model will become better and better throughout. So this particular loop is typically called as hyperparameter tuning. Hyperparameter tuning. So it's basically tuning up your parameters of the model, so that you try to make the model better and better. As and when you're making the model better and better, it will try to give much more accuracy. It will try to predict the loan eligibility correctly. It will try to predict the right amount of loan which can be dispersed and all that stuff. So the output of this entire modeling exercise is a model, which is the one which is helping us to do the predictions. So far so good. Are you following the this thing so far? So we have extracted the information. A huge amount of data is there. We will be able to extract the huge amount of information, put them into data lake, and then perform exploratory data analysis, which is doing all the pre-processing steps. And then after the data is cleaned, we are then applying the modeling techniques. The modeling techniques are variety of modeling techniques are there. So one of the example we are taking is the loan process, in which there could be classification or regression cases. So imagine we have classified that the person is eligible for the loan, and that will be extracted by one of the model. right? So once the model is created, like now imagine that the model is created, which is nothing but an extraction of your algorithm, which is trying to find patterns of all the data and then coming up with a general use case. And that extraction, you call it as a model, a technical name. That model typically will be deployed on some kind of a cloud-based service. Imagine I'm creating a cloud, really making a cloud, say like this is an AWS cloud. What we do is we need to deploy this model on the cloud. Now for deployment, for creating a model, you can use things like Flask and other things. For deploying a model, you can deploy using Docker. Now if you don't know what these things are, don't get worried. We will understand these things in great detail, but just for deploying the models and all, we might have to use some services like these will come under the ML ops and DevOps and other things. Now we will deploy this model, and that model can be deployed onto this cloud provider. Now model can be created as an API. API is nothing but application programming interface. Now the extraction of a model will be bundled in an API. So the API will be expecting some inputs and it will be giving some outputs. So that API can be triggered from maybe a front-end service. You're creating a front-end service. Now this is a website. This is a website which is basically gathering some information, and you basically can give this information about the loan applicants. The people can log into this website, say like this is some xyzbank.com, and person can log into the website and can give some information about the name, age and other things, and click a submit button. Once he clicks the submit button, it will invoke this API. It will invoke the API and give that information to the API. API will do some predictions, like for a given age, for a given marital status, for a given bank balance, for a given whatever, all the details. Or for all the details, you will have some kind of output, say like whether the person is eligible for loan or rejected for the loan and so on. So based on whatever data it is capturing, it will call the API and it will give back the results. Now this is called as the real-time inference. Real-time inference. Now what is a real-time inference? It's basically like calling all your, in a real time, you're trying to call the model, get the results, and then show the results back into it. Now this front-end systems can be built in, say like Angular or any other front-end technology, React, Vue.js, whatever common technologies are used, they can be created in these systems like Angular or React or Vue.js and so on. And the real-time inference is happening based on which you will kind of invoke the model and get the results. Now the inference can also happen in a batch mode. Now the same kind of thing can happen in the batch inference. Now the batch inference, in the batch inference, what happens is now your model will be deployed in the similar manner. In a batch mode, you create an API, but what generally happens is you will feed the data as a file to the model in a batch mode, and you will get the data as an output in a batch mode as well. So you'll feed some input file and then you get an output file. Now this can be triggered using some tools like Jenkins. right? So we are triggering the job and we are saying like, okay, every day in the morning, um, 1 a.m. or 2 a.m. you trigger this job, and the job will basically take an input. Now this is happening in a batch mode. So the input file will have like 100 people who have applied for loan. Now instead of having in the real-time mode where we're opening a website, entering our details and clicking the submit button, now we are doing the same thing in a batch mode where the bank clerk might get some 100 applicants. So that 100 applicants, we have created a CSV file that gets uploaded, and once that gets uploaded, the model will basically run through every record, and it will try to predict the eligibility of the person, whether he is eligible or not eligible, and based on that we will create an output file. And that's how it basically works like this. It basically creates in a loop. We are trying to identify different patterns of the data, and then we are trying to create a multiple loop, and based on that we will try to create an output. Now this is how it really looks like. So a real-time inference is where you are trying to access the data in a real-time mode. A batch inference is basically where we are trying to access the same in a batch mode, where you're trying to schedule some jobs. The jobs will be triggered at certain durations, and based on the outputs of the jobs we will try to create an output file, and the output file will also be used in the further process. In the output file, there could be another program which can look at the output file and then create an email saying that congratulations XYZ, you are eligible for the loan, and this is your loan approval letter. So it goes through every records of the output file and then creates an individual email, and that will be fired to the customers. So this is all happening in a batch mode. In the night, the job runs and everything else happens in a batch mode, and that's how it really works. There is one other thing which is called as data visualization, which again data scientists would work. Data visualizations. Now this is also an important piece where you might data scientists might be working on some other third-party tools like Tableau, Power BI, or maybe some internal tools like Seaborn, Matplotlib. So likewise, so what the data scientist would also do is, because he or she has to working with the data, he or she has to tell stories about the data, like what is the data speaking, right? So it is very, very important to tell like what is the data speaking, what is it trying to do, and other things. So the person has to explain, looking at the data, it has to explain that it has to explain like what things are happening with the data, what are the patterns of the data, and how these different data is explaining. So what went wrong, what is getting corrected, what are the what could go wrong. So based on what has already happened, we can draw some graphs and charts and patterns, and for that people needs to learn a little bit about data visualization. And some of the tools like Tableau, Power BI, and Seaborn, these are some of the tools which will be helping the data scientist for creating these cool graphs and creating some stories and visualizations of the graphs and so on. So overall, a data scientist, now if you are taking on the left side, we will talk about data engineer. This part is the data engineer. Somebody from the middle to the right side, we call them as the data scientist, somebody who is working on this part. It's a data scientist. Now, depending upon the experience level, so we might have a junior data scientist, senior data scientist, and different other things. But bottom line, the data scientist is the person who is responsible for doing exploration of the data, creating algorithms, deploying the models, and so on. And nowadays there are different role sets for just the deployment and interaction, creating APIs. So that role is called as ML engineer. So ML engineer is a person who is kind of responsible for kind of deploying the models and creating APIs, interacting with the front-end systems, and so on. A data scientist is a person who is responsible for creating the models and so on. Now, depending upon the company we are working, you might be on wearing multiple shoes. So you might be a data scientist, you might be ML engineer, you might be a batch engineer, or you might be working on the data visualization and also on the data engineering. So depending upon the type of company we are working, we will be using multiple, you will be wearing multiple hats and might be working multiple things. But when we are going to when we are going to some companies which are bigger corporate companies, service oriented companies, or maybe bigger product companies, you might be given specified set of roles. Maybe like you might be a data visualization Tableau developer, or you might be a data scientist or a junior data scientist. You might be a big data developer or a data engineer or a ML engineer. So the roles will differ, and you would have a clear-cut responsibilities depending upon the company you're working in, and depending upon where and how you are working, and what is the place you are working in, and so on. Right. So overall, what we have discussed today, it's a very jam-packed session. I would say your entire screen is again packed. What we are discussing here is we are trying to see like um, how the data comes, what is the processing happening, what are the different areas which are involved, and how the deployment happens, and all those things happens. And many times people will only get confined to the modeling, right? So people will say like, I will learn XYZ model, ABC model, random forest, decision tree, and other things. And people get just confined their learning to this area, only the modeling area. But as you're seeing, this is just a piece, just a one piece of the entire equation. Just learning the model, you will not know. Like for example, people will say in many machine learning courses or data science courses, they'll say that, okay, we are applying this model, we are getting 80% accuracy, and we are done. But that is not done. It is not even half done. So getting one accuracy or getting some better model is one just part of the equation. We need to know like how the data cleaning has to happen so that we get the best models. We need to say like how we deploy the models, how we club multiple models either in a real-time inference or a batch inference, and multiple other things are involved to really get the practical exposure or really get into the job, right? So that is something, it's a missing piece which I'm seeing in many of the people, is that they only talk about one of these models and then say that, okay, this is what is data science or machine learning. But there's a whole lot of ecosystem involved, and the person needs to have an awareness of, say, like how do you do cloud deployments, what are the data science ML tools required, what are the pre-processing applied, what are the different models to be applied, how do you do hyperparameter tuning so that you improvise the models. So a lot of these things are involved, which really helps to be a better data scientist, right? So I just want to check. Okay, so there is a question like, what is a prerequisite for data science? So prerequisite, I would say, you need to have a basic understanding of any of the programming language, preferably Python. So if you are familiar with Python, then it's very good. Even if you are not familiar with Python, it doesn't really matter that much. But I would say that you should have at least some familiarity with some other language, say like C or C sharp, .NET or Java or any other language, programming language, or maybe front-end programming languages could also be there, like JavaScript or any other things. So where you will be able to understand like how to construct a code, how to write a code, and so on. Definitely, there is Python is the most widely used language. You also use R, but nowadays R is dying up because the Python ecosystem is growing leaps and bounds. and because of that, Python is in adoption for many of the companies. Now, using Python, we would also need to learn about some of the tools. So as a part of our course, we will be teaching Python as well. So we will know, like, even if you don't know anything, we will teach Python, which is the basic for the entire course. So we will teach for what will be the libraries used, how to use those libraries, and other things which are required for data science. All those things will be taught during the course. So do we need R as well? We do not require R language. We would be using Python. As I said, R is slowly dying. So maybe in after few years you might not see R in usage that much. So Python is the go-to language, and that is what we will be using for the course. So just to give a few glimpse about the structure of the course. So first one, let me change the color to white. So this will be a 3-month course. If you're interested, and it will be daily, 1 hour duration, and it will happen from, say, like, depending upon the timings, it will happen every day in the morning. So Monday till Friday on weekdays, Monday till Friday on IST time zones. So for example, you are in US or any other part of the world, that would be your Sunday night to Thursday night. But if you are in India and or in other places, you have to look at accordingly, right? Imagine you are in Singapore, so that would be your Monday till Friday afternoon timing, right? So that's how you have to map accordingly. But this will be a 3-month course daily, and this will be the schedule. And from a topics perspective, we will talk about mathematics for data science first. So we'll talk about math for data science. It's very, very important to understand mathematical concepts. We will also talk about statistics for data science, math for data science, statistics for data science. Then we'll get into the Python for data science. Now this itself will take around a month. We will be doing a lot of work here. Then we will get into machine learning. Now, within machine learning, whatever we have seen, different algorithms will be covered, supervised, unsupervised, reinforcement learning, all those algorithms. We will do natural language processing. We will do deep learning. Deep learning involves about complicated data types like image, video analysis, and other things. And last but not the least, we will do cloud computing. Now, cloud computing for data science is very, very important. It is a very deadly combination, cloud computing and DevOps. Now, what is so cloud computing? I'll be covering about AWS because I have good experience in AWS, but the same things can be extended to Azure or Google Cloud. In DevOps, we'll be covering about how to create Dockers, how to create Kubernetes-based clusters for deploying the models, and so on. But this last two models will help us to understand how we do deployments in the real world, like how do you create systems to deploy the models in the real world. So these are deadly combinations, where the data science part we will get the depth, and cloud computing and DevOps we will get the breadth. So I kind of draw this kind of a T-shaped structure in which we need to learn data science, which gives us the depth, and we need to learn cloud and DevOps, which gives us the breadth. We don't need to have full knowledge on cloud and DevOps, but we need to have an understanding, like how do you deploy, because these are the connecting pieces. Now you just say like I will create the model and my work is done. That doesn't work in the real world. You need to see like how that is deployed, how it is connected, how it is taking the data, how it measures the drift in the data. A lot of things are involved here, so you basically have to understand all the pieces which gets connected. So for that, you need to have awareness on the breadth also. Apart from the depth, you need to have awareness on the breadth also. And this is how these concepts will be involved. So we would also help in interview preparation and other things. So after the course completed, you would also get some kind of referrals from the company. But that is not hard and fast that you always get complete job support and all those things. What we are saying is we would recommend you to the companies. We know a lot of companies, so that we can recommend you to the companies, and getting into the job is your work. We will help you get the interviews done. We will help you to create your resumes, how to answer questions, what are the important probable questions which will be asked. So all those things we will be covering as a part of the course itself. All right, any other questions? I think this is an important slide. Please look into it and just let me know if any questions you have. Is the pace okay for you guys? Are you understanding?
Yeah, yes.
So any other questions?
So yeah, thanks Sitaram for walking us through the entire ecosystem. So I have one question. So as part of this data engineering and data scientist and then ML engineering, so we are mostly covering with the data science scientist and ML engineering roles only, right? Not the data engineering role.
Yeah, so this is a data scientist course. Of course, data engineering role would require some more months of expertise or understanding. So, talking about big data related tools and other things, that is a completely different course. So I am talking about data science part, but we would also cover a little bit of understanding about, how those areas are involved, like how data will be coming into one of the data lakes, and how other big data engineering tools will be used. But we will not be doing a deep dive into those areas. That is a completely different topic altogether.
Yeah. So as like when it comes to the practice, actually that makes that clears my question. So yeah, even that's what I'm expecting. So a little bit of understanding on data engineering would help to get good knowledge on what a data scientists do. That's why I asked that question. And
That
yeah,
that
the other thing is yeah, sorry, continue.
yeah, that will cover anyway.
Yeah, yeah. And the next question is as we are not going to work completely on this data engineering thing, so how, as part of our practice, how are we going to get this data? Do we have any dumps where we can work on this data scientist role, or how exactly we are going to do this
Yeah, as a part
practice?
of the practice, so there are a lot of data science. there are a lot of data sets. So throughout the course, we would be having a lot of practical data sets. There will be 20 plus projects we'll be doing throughout the course. This is a project oriented learning, and as and when we are doing the projects, the code associated with the projects and the data sets associated with the projects will be uploaded in the drives for you, so that you can download them and then practice and do your practice at a different point in time. That's one part. And every day the sessions will be recorded, so that even if you miss one of the session, you would be getting the recording the same day or maybe the next day, so you can go through the recording and then practice your problems. So we will be doing 20 projects, 20 plus projects, I would say, throughout the course. These are the mini projects. So while we are learning the algorithm, instead of learning the algorithm in a normal way, we will be learning through the project itself, so that we will know like how it is built in the real world. So that exposure we will be getting while we are doing the course itself. I would ask the organizers to send you the curriculum. There is a pre-built curriculum which we have created, which will have a clear understanding of what are the topics which are covered.
Yeah, I think we already got that the as along with the link that they have shared. So can you go
Yeah,
back to the first slide? Yeah, so here this for this data analysis and modeling, there are n number of techniques, but like as you mentioned, for data analysis, there will be pre-processing, transformation, and coding. So these are the different techniques or different things that we need to apply to get to remove the garbage. So do we have any specific tools that we use at these different stages, or is it only the code that we need to write to do this?
tool-based thing. There are some tool-based thing. Cloud-based tools are there for doing data pre-processing, but those are not yet matured enough. Maybe in the coming years they can get matured, but at this point, people are relying on writing codes. But what we do have is we do have templates for these codes. So once we do the course, we will get all the templates for creating this entire project. So for doing certain kind of transformations, we will have templates. So all we need to do is attach all the templates and then kind of create a pipeline, so that whenever the data is ingested, we can pass the data through all these different template pipelines, and it will do the pre-processing, whether that could be transformation or encoding techniques or scaling techniques. So while we are learning the exploratory data analysis, we will also learn about what are the important code snippets and how to create a template. After the course, you'll get the template, and then you can use that for your process.
Okay. Yeah. Thanks for that.
Any other questions? So there is in the invite itself, they have also given the link for the curriculum. I would recommend to go through the curriculum, because the topics which I've just explained in a very basic manner, but talking about the projects involved, or talking about the different topics, what would be covered in the math for data science, what would be covered in the statistics or machine learning and natural language processing or deep learning. We have given very clearly like what will be covered. So it's a very comprehensive course which would be involved practical learning. If you're really interested, definitely get in touch with one of the organizers. They will guide you in an even better manner. If you have any technical questions, you could talk to me, and they will like actually involve me in all the discussions. So you can talk to me and clarify any doubts. So if you have any questions right now, just take a few minutes and then ask. If you don't have any questions, we can happy to close the session and enjoy your Sunday. or your Saturday night, whatever that is.
Hi Sitaram, this is Sudhakar, and thanks for your demo. Actually, I am working as a system admin, so I have knowledge on AWS and Azure. So, but my question is like, I don't have any programming language,
Hmm.
so how it would be helpful for my job profile? Because I have uh, almost 10 to 12 years experience in the server side.
Right.
So
So,
now if I want to change my profile to um, admin to data scientist, so
hmm.
what your suggestions?
Yeah, so I would not say straightforward you can directly jump, but there are pathways in which I have seen many people, I've seen so many people who are having similar expertise who are navigating. So I can give you the pathway. The one pathway which is very commonly used is, going through the data engineering, data lake setup, and coming into the data exploration. So this way, where
Mhm.
you require a lot of data ingestion things to be done, people need to have an exposure on Linux administration or AWS administration or Azure data lake setup and data, storages and processing and so on. And so the best entry point would be this area. And once you have entry, then you can get into slowly into the exploratory data analysis where you can use some pre-processing tools and then slowly can get expertise in the some language and get as a data scientist. But the entry point would be this area where you are creating data lakes. And those data lakes can again be on AWS or Azure, and
Mhm.
then slowly navigating into the other areas. So I would not say like directly jump into the data scientist kind of a thing. That is eventually the final goal, but the entry point should be from this side. Similarly, if somebody asks like, I am a web developer, like how do I get into this area? I am interested. So the web developer, entry point will be from this area where they could become an ML engineer, can integrate, create Docker systems, create APIs, integrate with front-end systems, apps and mobiles, and then slowly navigating into the data scientist, this area. So, as straight answer for you is, entry through the data lake creations and storages and other things, and slowly navigating into the exploratory data analysis and other path. But I have seen people who have done that. The good thing is like if you're already having some system administration experience, because this is all involving with system databases and storages. So
Mhm.
there is a lot of backend work which is already happening. And if you are familiar with AWS or Azure, then there is a good entry point. Like rather than somebody who is completely not linked with those things,
Mhm.
there is a good chance of entry here.
Yeah, most of the part like data engineering parts, data lakes. I know some concepts in Hadoop, but most comfortable with Azure and AWS.
Right. Right. So that is an entry point, Sudhakar. As I was saying, that will be the entry point, but slowly, because that can get automated in the coming years. Now, people are automating everything. Now, you can create pipelines which can automatically launch servers, reboot servers, and create data storages, increase, decrease
Yeah.
storage capacities, and all. So it's always better to slowly navigate into areas which are much more human intensive, so that you have a hold on this area, but also you're slowly navigating to other areas which can give a bigger ground.
Okay. Yeah. Thanks, Siddharth.
So Sitaram, like sorry, 1 minute. So in the AWS, what is that we use? Like, are we going to use these S3 buckets or EC2 instances to deploy our APIs? Like, where
Yeah,
exactly
so
we're going to?
data will reside in S3 buckets. You can launch virtual machines on EC2, or you can run EPS Docker containers, or
EBS.
yeah. Similarly, you could run systems. We would be learning about how to launch data from S3 buckets, how to launch EC2 machines, how to create virtual machines, how to deploy models on EC2 machines, or how to deploy models on using Docker on EC2 machines and launching them as end-to-end web services and so on. So that is what we will be targeting on, but you can go deeper and do a lot of things. So, but our focus would be understanding how the deployment happens in the real world. So those are the topics would be covering. So for people
Okay.
who do not know what I'm talking, don't worry, but those are some of the services in an AWS side, which will help us to deploy the models and create our web applications.
So we will have the logs enabled, right? Even in these APIs as well.
Logs, yeah, definitely logs
Like
will
to
be enabled.
debug and all. Yeah. Okay. Yeah. I think someone I have disturbed. So you please carry on.
Any other questions? Yeah, other people.
Hi Sitaram, this is Sai. So I have a question regarding like which role is good. I think my question is like most similar to the Sudhakar's question. So my role in the current company is like I work as a developer, like much into the production support. So like from where is it a data scientist role is good for me, or data engineering is good? Like what would you suggest? I work as a .NET production support engineer.
So if you're already having a development experience, I would say like you could pitch into a junior data scientist role, navigating through the ML engineer role. If you are like a .NET production support, or Java, or front-end developing, or application developing, such kind of skill set is there, then ML engineer is the best role to get into, which will involve application integration and creation of the models, deploying of the models, and some bit of modeling will be involved. So entry point will be ML engineer, but you can slowly navigate as a junior data scientist and then work in this space. But this would be the entry point, right? How do you deploy models? People will be requiring an ML engineer for creating Flask applications, creating APIs, which can be invoked by the front end applications. That could be .NET application, or a Java application, or a Angular, or a React application. So we need to know how the interaction happens and all that stuff. So somebody who has already worked in that space will be able to easily penetrate into this, and that will be the interaction area.
Okay, so it's like my role is not much into coding, but yeah, I work on coding, but not much. So, like, can I match with this role? I have worked on support tools actually, Jira and all those.
Yeah, those are on the support perspective. Those tools are the operational tools. But if you want to get into this, you need to have some coding experience. So I would recommend you to have some basics on Python, because you already have worked on some kind of language. Even in the production support, you need to have understanding of how the application is built and what to change, what to fix, and other things. So I assume that you have that kind of an understanding. So if you can upgrade yourself in one of the language which is used in data science, like Python, then definitely that will help you penetrate into this much easier.
Okay, so that level of Python, I mean the course content, what it is based on the curriculum. So are we going to cover from the basics, or it is like intermediate level?
It will be intermediate level. If I start talking about what is a variable, what is a class and all, it will not be in 3 months, it will go for 6 months. But those basic materials are freely available on the internet, and definitely if you want to do a course, Career IT also provides some Python basic course. You can also talk to them if you want to upgrade yourself on that path. I've seen people who have doing both, Python parallelly with data science, and they will get brush up on the Python language, and they can get into the data science part. But one thing I would say is, so anything, not only data science one, anything would require an effort. Definitely, it's not an easy cakewalk. If that is the case, then everybody would be coming into this area. So that is not a real case. If somebody says that it is very easy, you can easily get a job and all these things, then they are fooling ourselves. We need to put our good effort. We need to know the right entry points, like as other people were asking, from a Linux administration perspective, this is the entry point. From a front end perspective, this is the entry point. Maybe you are a batch administrator, you would have batch jobs or something like that. Your entry point will be like this. You may be a database administrator. Again, your entry point will be creating databases, managing them, and other things. So you need to know the right entry point so that you can concentrate on that area and again deep dive or focus into other areas. But definitely it would take some effort. It's not like an easy cakewalk. You need to spend a good amount of time, at least 3 months to 6 months is what I recommend. And once you are comfortable, definitely you can pitch into some of the job profiles and so on. All right.
Yes, I got it, Sitaram. Thank you.
All right, thank you very much, and I hope you like the session. You might have got some insight of what is happening, what are the different linking pieces, and how those are connected, and so on. Should give a decent understanding. And if you want to deep dive and do a course, feel free to talk to the organizers. They will give you more information. And the course would start maybe in a week or so. We will schedule the right time and inform you. We can start the course. All right. Thank you very much and have a nice weekend and enjoy your Sunday. Hope to
Thanks,
meet you
and wish
soon.
you the same, Sitaram.
Yeah. Bye.
Thanks, everyone.
Thank you.